Hello and welcome to this AQA Further Math Statistics video, the first in a series looking at errors in hypothesis testing. And this first video is looking at the definitions of the two errors that can occur. So first of all, if we just think about carrying out a hypothesis test, generally speaking, when we carry out a hypothesis test, we're just making a decision on a population parameter based on just one sample of the very, very many potential samples that could have been collected from our population. And therefore, the fact that we're using this one sample, any conclusion that we come to must be considered in the context of all the possible samples that could have been collected, and the fact that we're only looking at evidence based on just one of those possible samples. And you should be aware that any conclusion to a hypothesis test is never definite. We can never absolutely say something has changed or something hasn't changed. We can only state that based on our significance level, we either do or do not have evidence to accept our null hypothesis. So the two definitions for our type 1 and type 2 errors, and this is quite a weird concept when you think that you've carried out a hypothesis test perfectly correctly from your sample and actually you could have come to an incorrect conclusion. But hopefully you'll see when we look at an example in a minute that indeed that can happen. So a type 1 error is when we incorrectly reject a null hypothesis. So we decide that we have evidence to reject H0 and we're going to conclude that a change has happened. And this could be thought of as a false positive, because although we concluded there is a change, in fact that's incorrect. A type 2 error is when we incorrectly accept the null hypothesis. So in that case, we're saying that there is no significant evidence to reject the null hypothesis. We don't think there's any change, and in fact that's an incorrect conclusion because there has been a change. We just didn't notice that in the sample that we were looking at, and that would be called a false negative. We didn't find a change and actually there was one. So if we look at this in terms of a very simple little scenario here, and there are no population parameters involved, we're just looking to see whether a new treatment cures a disease faster than a current treatment. So what are the hypotheses going to be for that? And just as you would normally do, our null hypothesis is no change, so the new treatment takes the same length of time as the current treatment, and our alternative hypothesis would be that the new treatment cures the disease faster. So think about the conclusions that we can come to if we either accept or reject our null hypothesis, and I will then show you in the next slide how that can go wrong. So think about the outcomes of carrying out your test. You're either going to conclude that you're going to accept or reject the null hypothesis. That's your decision, your conclusion. And now let's consider here the actual true state of our null hypothesis. Is it in fact really true, or is it in fact really false? Because we don't have that information, but because we're basing our decision on a significance level, on a probability, we could always get it wrong. There's a very small chance, but we could always get it wrong. So if we end up accepting the null hypothesis, the new treatment isn't any faster, and in fact that is the case, then that's fine. We don't have a problem with that. If we end up rejecting the null hypothesis, and in fact the null hypothesis was false, the new treatment is better, is faster, then that's fine too. But what about these cases here, where for whatever reason the data in the sample we had led us to make the wrong conclusion in terms of the true state of the null hypothesis? Well, what are the implications of that type 1 or type 2 error? So if we think about a type 1 error, what does this actually mean? So H0 is true, so the new treatment isn't any better, but we end up rejecting it. What's that going to mean in terms of the staff, the medical service, the patients? What are we going to think about that? And secondly, if the null hypothesis is false and in fact the new treatment is better, but we end up accepting the null hypothesis and saying there's no evidence to doubt the new treatment is exactly the same, what would be the implications of that? So if we look at our type 1 error, the new treatment's going to be used. That might have cost implications. Patients are probably going to know that they're using a new treatment, and they're going to believe that this is going to cure their skin disease faster, but in fact that's not the case. So you're going to end up with very disappointed patients and possibly quite a lot of expense that wasn't worth it because the new treatment actually isn't any better. If we make a type 2 error, it means that actually the null hypothesis is false. So actually the new treatment's better, but we didn't pick up on that from our sample. Therefore, patients are going to be stuck with the current treatment and they'll have to suffer for longer waiting for this disease to clear up when the new drug could have helped speed that process up. So again there you've got disappointed patients. So let's just think about a type 1 error. So we get a type 1 error when our sample data just appears to show that there is an effect of the treatment, there is a change, but in fact there isn't any. It was just the way the sample data happened to come out from our population. And every hypothesis test you do has an associated significance level, and that is fixed as the probability that the null hypothesis is rejected when it's true. So it's the basis of very small probability of something occurring, bearing in mind the null hypothesis is correct, that will lead us to say no, because what I've seen would only happen such a small percentage of the time, I think I have evidence to reject the null hypothesis. So the probability of a type 1 error is always equal to or less than the significance level of the test. So how can we have type 1 error? Well, we're rejecting the null hypothesis based on our sample data, and that, as I was saying, it's normally because you just happen to have a freak sample. We just happened to get a sample where we got an extreme result, so our test stat fell into the critical region, even though actually the treatment had no effect. With a type 2 error, this means that our sample didn't appear to indicate a treatment effect. So we just happened to get a sample that did not indicate a change. So how could that happen? Well, often type 2 errors are the result of what's called a small treatment effect. So possibly in our scenario here, our new treatment did make the skin disease be cured faster, but it wasn't much faster, so there wasn't a huge difference to pick up on. So it might have an effect, but it wasn't large enough to show up. And sometimes in that case, a larger sample size might be needed. And often in medical trials, they do pull results from lots of different trials that they've done, so that hopefully they can pick up on any treatment effect if in fact there is one there. And that's the end of this video.